everybody who is watching this video. My name is Olenjolai TAYAI single from beautiful, fantastic country of United Republic of Tanzania. I would like to take this time to welcome you onto our online Polytechnic Institute that is called the Online Diploma Polytechnic Institute of Tanzania, in square bracket Olenjolai. Okay, so the vision we have in this Online Diploma Polytechnic Institute of Tanzania is we want to prepare a community, or to be a part of preparations of a certain community of students who are ready to take scientific and engineering classroom instructions to solve real-life problems in their community. So that's the visions of this program. Our main vision, our vision is not to help students to pass the exams, however that it will be a part of. And in this online platform right now, we have just online platform. We don't have a physical institution at the moment. But also we are trying to help, firstly, before we come into the practical or the applicable area, for instance, that the area of electrical engineering, electronics engineering, telecommunication engineering, biomedical engineering, mechatronics engineering, computer engineering, so even computer science. So before we teach our students about different concepts on those perspectives, we would like first of all to build a strong foundations on this area, which is fundamental of all the courses, which we call basic engineering and scientific mathematics. So that's the first department that we have in this online platform, but there are some other departments also that are going to contribute too much details later. For example, the departments of computer programming, and also the departments of the language, which actually that will be training about the human language, because there's a human language and computer language. So we are very happy to be with you today, and even to impact your life greatly, because we know that we are going to take you from one point to another point. So that's I would like to remind you the vision of this Polytechnic, of this Online Diploma Polytechnic Institute of Tanzania. Another thing which we like to remind you frequently is I was born to solve a problem or problems, and I call them, I was born to solve a real life problem or to solve real life problems. So what problems am I solving here? It happens that when I was doing my undergraduate studies, I realized that many ordinary diploma students in United Republic of Tanzania, in many of the technical institutions, even universities and colleges, they really suffer a lot on understanding basic engineering and scientific mathematics because of various reasons. There are many causes that just led them into that point. But what I realized when I was in my first year of my undergraduate education, I realized that the students who have been gone through different engineering programs from first year to the third year, from the first semester to the sixth semester, they have been suffering a lot on modules of basic mathematics and the scientific mathematics. So some of the reasons you find that they have been discouraged in the class when they have been taught, and even another reasons you find that even the students, you might find that they are lazy on learning mathematics. Some of the reasons also, you find some of the students expect to get help during the year examinations time by different ways, and even including the illegal ways. So how are we going to solve that problems? That's the good questions, right? So we are going to use different teaching aids, different teaching techniques, different teaching approach, different teaching methodologies, and different teaching styles, so that we'll be teaching our students and teach them to think differently. And just I would like to open their minds and their eyes to see the beauty of basic engineering and the scientific mathematics for the rest of their life. And again, that will make sure that every student who is going to take this program, he or she is going to love basic engineering and scientific mathematics for the rest of his or her life. So that's the way that the methodology that we are going to use. We are going to solve many problems, and we are going to break. We know that there are some of the complex concepts in basic engineering and scientific mathematics, but we'll break those concepts into smaller and smaller and simple and simple and simple. Because we engineers, we have to design systems that solve real life problems. So in order to have that, we should have a mindset of mathematics, of how we can think around on designing our system, on designing a particular system, for example, just design those different part of the system that is going to solve a real life problems. Similarly, scientists even actually they have to think even differently and even in a higher level compared to the engineers, because they want to solve real life problems by using the pure and the research science. So that's what we are going. So we are going to teach students. We are going to motivate them. We are going to actually to teach them to think differently. So we are going to do a lot of things, not only the matter of teaching. But another thing which we want just to give you a guarantee, since this is my 11th year when I have begun seriously, this is my 12th year when I began to teach students from all level of ordinary level, it means ordinary secondary school. Then I taught the next level, it is ordinary diploma students in engineering and science courses. Also I taught advanced secondary students, right, in science and in physics, in mathematics and chemistry. Also I taught undergraduate students. I taught them higher and I'm still teaching them higher engineering and scientific mathematics. So through the years, I will be taking all the experience and techniques that I've been gathering on teaching students physically, and then use them effectively, so that every student who is going to take this course, whether you're a slow learner, whether you're intermediate learner, whether you're a faster learner, it's a guarantee that you are going to understand what I'm going to teach you throughout this course, right? Another thing, that we have a guarantee that if you'll be doing everything that I'm going to ask you to do, you are going to do the homework, you are going to take different questions, you think mathematically every day in your life, the issue of passing the test, it means that the tests or the assignment, for example, will be given as a class assignment or quizzes or exams, it won't be a critical problem for you. It will be just like a part of your life. So that's another second guarantee that God will give you in this program. Another thing, that before we go inside today's session, which is into today's lecture, another thing is Olenjolai does not know everything about basic engineering and scientific mathematics for the ordinary diploma student. I just know small portions of it, but I'm ready to teach you that small portion that I know to millions of the students. So if that's the case, now you're in a good positions. We want serious students, and if you're not serious, we are going to train you how to be serious, right? So it's a time right now that we have to go through. Make sure that you also you see a software button that has been written subscribe. So this is very important procedure that you have to do in order for you to get notification, because we are going to upload more than 100 videos, and at least a day we can upload one video in these platforms or in our YouTube channels that called the Online Diploma Institute of Tanzania. In square bracket Olenjolai, Olenjolai. So Polyinstitute, this is a combination of the two words, Polytechnic Institute. So make sure that you click these buttons once, and then still change to, and it is being written that you have subscribed, and the color of the background change and the color of the text change. If you're using a computer, again, you will find that you have a bell, right? So you have to click this bell and you choose the options of all. When you accomplish that process of less than 30 seconds, then you'll be given notifications by the YouTube community once we upload any new video, and at the time when you'll be online. So I believe that now you're in a good position. Take your exercise book, take your pen, take the reference books that I've mentioned. Again, that before we go through this one, I would like just to give a brief introductions. We are in departments of basic engineering and scientific mathematics. The module of the course is called the conics and the differential equation. In some of the institutions or some of the colleges or universities, they call it the coordinate geometry and ordinary differential equation. So regardless of the name, the issue is the contents. This is this module is a year of study in many institutions, many engineering and scientific institutions in the Republic of Tanzania, even in Africa or in the world. This is the first year module, and it's NTA level 4. So it's National Technical Award for NTA level 4, and you are preparing technicians. So get prepared to be amazing and fantastic technicians. So the main objective in this online polytechnic institution, we are preparing fantastic and even unique technicians. And by the grace of God, they're going to change the world, and they're going to change the country, they're going to change the community. Okay, so now let us go. So we have done the first 2 sessions. The topic of the chapter is, we'd like to teach because we say that we have conic sections. There's 4 chapters we have to cover: cycle, parabola, ellipse, hyperbola. Right? So we have started with this chapter 1, which is cycle. Then we go to other chapters, and we did in session 1. So you have to go through, which is question of we did session 1. So you have to go back to session 1. So we go to session 1 or lecture 1. Think that because you are an undergraduate student, the sounding word is this one, lecture 1. Lecture, so this is lecture 2. So you have to go through lecture 1, and also you have to watch the video which has been written at lecture 00, the general introductions of basic engineering and scientific mathematics for ordinary diploma, NTA level 4 to NTA level 6. It's all of those videos are still in this YouTube channel. So let us go into the quick review of the lecture 01. Okay, we don't we have to go through because at this moment we have videos of a video of lecture 00, okay, for conics of which about the third year students, and then see 01. So we want to do the quick review of 01. So in lecture 01, what actually that we didn't do a lot of work, but we just introduced to you about the contents, right? Contents. So basically that we have given you some information. Basically this is contents or topics, right? Of 40 of conics and differential equation. Okay? And differential equation. So these are the 2 branches of 40 of mathematics, right? Conics is a branch of mathematics, which is one of the part of 40. It's a part of, we call it, just conics is the part. Conics also we can define as, yes, it's a part of geometry, right? So it's a part of the geometry. So we mentioned about contents, and then we say that we have mentioned the contents for the conics. I will mention for the differential equations later. And we say that conics, it has itself, it's a main topic, and then but it has 4 topics: cycle, parabola, hyperbola, and ellipse. Then contents of the cycle, we say that I'm going to teach about introduction of the cycle that I made in session 1, derivations of the equation of the cycle passing through 3 points, conditions of a straight line to be tangent to a line, equations of the tangent and normal line to the cycle, then internal intersections of the cycles and external intersections of the cycles. Then finally we'll complete that's this topic by learning orthogonal intersections of cycles, right? So that's the business that we have. So in general introductions of the cycle, first of all, we ask ourselves how we can get the cycle, right? So it means that another concept that I told you, that cycle is obtained. So obtained from what? Obtained from the conic section, right? From the conic section. From the conic section. Again, another question or another thing that you have to think in our mind, that if that's the case, you have diameter, we have radius. Okay, so we define the cycle. What the cycle? So I gave you 2 definitions. Let me repeat one. Is a locus of the point which moves so that it is always equidistant from the fixed point. So I give you a definition of what of the cycle. And then I told you the derivations of 40, derivation, which I'm going to repeat soon, the derivations of 40 of equation of the cycle centered at 40 at original of 40 origin of XY plane. That's what we have done with you, right? Okay, so today let me take you because according to the equations of the cycle, let me take you into interesting last part of session 01, derivation of equation, right? So equation which is EQ, equation of the cycle, of the cycle, derivation of this equation of the cycle, right? Centered at the origin. Centered at origin. So let us follow. I'm going to follow some steps just to remind you. The first step, we say that, okay, consider that I know that you will understand. The God who called me asked me to repeat it because he didn't understand this concept very well. Consider the cycle with center A, B and the radius and radius R. Okay? At the origin of 40. Okay, center 0, 0, excuse me, 0, 0, okay, at origin of XY plane. So what does it mean? Suppose that this is our XY plane, this is Y axis, and then so you have the X axis, right? So this is the X axis, this is X axis. So X axis, and here we have origin, right? So if that the original point, we say that suppose we have a cycle. My cycle might not be having constant distance from the center, so you have to make sure that you use a coin, especially coins of the 200, to draw it. Okay, so this is our cycle. Okay? So, what do you say that? We say that suppose this is the origin. So here we have 0, 0, and then suppose that we have a certain point here, which we call the point P, which is X, Y, right? Because this is the XY plane. And then the distance from the center to the end point of the circumference is what we call the radius. So remember that the center here, for instance, that if we write, okay, the center is 0, 0. So what do you say? So again, this point here, suppose it is point Q. And this point Q, right, just to write its coordinates, the first coordinate is X, right? And the Y coordinate is 0, because it's on the X axis, right? So we have R, now we have a right angle triangle. Okay, suppose that at the point, you can take this point at this point, or at this point, or at this point, but don't take consideration the negative x-axis or the negative point. So now we have a triangle T, you have a triangle OPQ. I have to repeat that so that you may understand. Also, you may use, in case you feel from your heart you want to offer God, the mighty God, your thanksgiving offering. You can offer it through this program. You can offer it through this telephone number 0759 745331. So many lectures of diploma, ordinary diploma level will be in air and will be through the internet, so you can enjoy them anywhere in the world at any time. It's a time now when the light of engineering and scientific mathematics is flashing. It's flashing, lightning in Tanzania. So second step, we say that now, well, consider the right angle triangle, right? The right angle triangle. right? The right angle triangle. So the right angle triangle are OQP. When you consider it, this right angle triangle, right? This is the right angle triangle. Then we can apply Pythagoras theorem. So by using Pythagoras theorem, right? To the right angle triangle, we say, what do we say? This is the hypotenuse. This is, suppose that this is the angle, right? So here we have an angle theta. So this is the hypotenuse of the angle. This is opposite of the angle. This is the adjacent side, right? So according to the Pythagoras, we say that OP square is equal to OQ square plus QP square, or PQ square. So we say that according to the Pythagoras, so OP square, okay, OP square, this is equal to OQ what? OQ square plus what? PQ square. Right? Interesting. You have to enjoy the beauty of basic scientific and the engineering mathematics. So stay tuned. Have such kind of high expectation, because I'm going to try my level best to restore your love on this business. Okay? So OP, the line segment OP, right? The line segment OP is called your radius, so it is r squared. And then OQ now, if you want to find the point OQ, so we say that OQ, the line segment OQ, this one, we can find it by using the coordinates of Q, the coordinates of O. The coordinates of O is 0, 0, and the coordinates of Q it is x, 0. Right? So because that 0 minus 0, so you say that the distance of OQ, for that case, the one defined is x minus 0 square. Right? So this r square is equal to OP square. Well, so we need again to know the PQ. Right? So the PQ, where is the PQ? PQ is from here to here. How do we get this distance? We use distance formula, right? The distance formula we subtract the x coordinates and y coordinates. So it means, for instance, for this case, we take x minus x, because the distance formula square, plus what? And then we take y minus 0 square. But because you are looking for the distance, hence this is what we get. So the distance PQ, for that case, x minus x is equal to what? Is equal to 0. So it will be 0 plus y minus 0 is equal to y squared. So even here x minus 0 is equal to x squared. So now, if that the case, that we can say that fine, well, suppose that this is equation 1, and this is equation 2, and this is equation 3. So the steady state of the derivation, we say that substitute equation 2 and the 3 in equation 1. Right? Simple, like that. So now we can get the general equation of the cycle in the xy plane. So if you substitute, you get r is equal to x squared plus y squared. So therefore, we say that the general equation of the cycle centered at the origin is given as x squared plus y squared is equal to r squared. So we can put this bracket. Okay? You can put that box. Don't do that in exam. Okay, so that is all about the derivation of the equation of the cycle centered at 20 at 0. So now I want to take you on to the next step. It's derivation. I want to teach you how you can derive the equation of the cycle passing through of the cycle translated. So equation of the cycle, equation of the translated cycle. Equation of the cycle, equation of the translated cycle. And this cycle will be translated from what? So we are going also to follow some steps to accomplish this business. Equation of the translated cycle. Right? Translated cycle. And this cycle is translated from origin. Okay? From origin. Then, first step. The first step we say that consider the cycle. Consider the cycle with center A, comma B. A, comma B. A, comma B, and radius R, RT. Center A, comma B, and radius R of the cycle. So what does it mean? We say that, what does this mean? Previously the cycle was here. We want to translate it. How we translate? For example, we can translate this cycle into the first quadrant. We can translate it into the second quadrant. We can translate it into the third quadrant. We can translate it into the fourth quadrant. It means that we can translate, we can shift, we can move this cycle into this side, or we can move this cycle into this side, we can move this cycle into this side, we can move this cycle into this side. So the translated cycle, okay, of the translated cycle, so the translated cycle is a cycle whose center is not at origin, but it's any point along the XY plane. Let me repeat. That a translated cycle, when be asked by your son or by your children, right, mother or father, what the meanings of translated cycle? Tell them that's a good question. It's a fantastic question. Translated cycle is a cycle whose center is not at origin of the XY plane, but is somewhere else, anywhere else along the XY plane. That means of translated cycle. Okay. Or you can go to shift whatever that you call. Before I draw that translated cycle, let me just write a point to have. You say that translated, we enjoy the beauty of mathematics. Translated cycle, right? Translated cycle is the cycle whose center is not at origin of 40 of XY plane. Okay? So let us sketch. Okay? So suppose that this is our XY plane. Okay? This is our XY plane. This is our XY plane. Okay? This is our XY plane. Okay? This is Y axis. This is center 0. Okay? This is origin 0, 0. okay, y-axis, and this is x-axis, excuse me, this is the x-axis. So this is center. So now, suppose that our cycle is translated onto the first quadrant of the XY plane. So remember that this is first quadrant, and this in mathematics we call it second quadrant. We taught you in trigonometry. This is third quadrant, this is fourth quadrant, right? So this is the center. And we say that the center of the cycle is O. And then we say that, yes, we say that is point O. And the center is A, comma B. So this is the center. Suppose that we want to take a distance, a common distance, or equidistance, this point, just like this one, okay? And this distance is R, right? And then we have again this horizontal line, just like this, okay? So this is the horizontal line. Okay, this is the horizontal line. Then here we have an angle. Okay? So this is point P, and we have x, comma 1. Suppose also to be to have this is the right angle triangle. Suppose that this is point Q. And today point Q, its coordinates will be x, comma what? X, comma certain y. Right? So x, comma a certain point of 40 of y. Because this is x value. And this is what? Y value. But the y value for this point is what? B. Right? Because point Q and point O, they are on the same what? They are on the same axis. So the same value. So mean that when you say that that's the center, the value of B is B, the value of Y is B, and the value of X is A at this point. So this is X and this is A. Right? So that's why that's very important to note the coordinates, because we need those coordinates in our derivation. Okay, so if that's the case now, we like also to consider the right angle triangle. In case that you have any question, don't hesitate to ask your question in the comment section. Okay. So remember that this is just a description. The figure that this is now, it is figure 2, figure 1.2. The first one was figure 1.1. This is figure 1.3. Okay, so we go for the second step. The second step, we say that consider the right angle triangle. So suppose that is the symbol for the right angle triangle, right? Right angle triangle. And this right angle triangle, it's all QP, or P or Q, whatever that you call it. So if you consider that right angle triangle, let me draw it clearly, possibly you cannot see it there. This is R. This is point O. Its coordinates are center A, comma B, right? And then here we have point P. The coordinates are X, comma Y, because it's any point along the cycle. So this is the one, this is the point of the circumference of the cycle. Here we have a right angle triangle. Here we have a certain angle theta. And then this is what, this is point Q. So the Y coordinate of Q and O is the same, which is B, not that. And the X coordinate of Q and P is the same. It is what? X. So it is X, comma P. Interesting. Okay? So you see the beauty of basic engineering and the scientific mathematics. It's beautiful. It's real. It's beautiful. I like it. I like it. Okay. So if that's the case, that now we've considered that the right angle triangle, you saw everything that there. So we say that first of all, we say steady state, right? Say that let us recall, and use what? Use distance formula, right? Distance formula to find length of what? Length of sides of the triangle, of each side. Of each side. Okay? So, you remember the distance formula. Distance formula